Good morning. Enjoy the joke of the day. That's a good one. I like that one better than yesterday. All right. Even though you don't have notes for the organic reactions, I wanted you to do those for today. I am going to fill in the notes that I have, and then if you want to use my notes in addition to what you've done, you're welcome to do that. The test is going to be due, I posted it yesterday, 3:15. I do want you to do these Regents Review Book questions on organic reactions, and then I think probably we'll do a Google Meet tomorrow, which is Thursday at 1 o'clock, and then I'll do another one on Friday for any questions before your test, if you want to do that. Okay, so since there was no homework really to go over, let's go right into that. So, as you can tell if you already looked at the test, there's not a lot of questions on the organic reactions, but I think it's important that we still go over them. In general, if you have a saturated compound, we're talking about the alkanes. Remember, they're saturated with hydrogens. You can't fit any more hydrogens on there. They're relatively unreactive. There are certain things that they can react with and will react with. But if you have unsaturated compounds like the alkenes and the alkynes, they are more reactive. And they tend to react with chlorine gas, bromine, and hydrochloric acid, HCl. However, in general, they are less reactive than your inorganic compounds like sodium chloride or anything else that's ionically bonded. Why? Because these bonds are pretty strong. Remember, in order to have a chemical reaction occur, if you've got a compound that is a reactant, it has to have its bonds broken before it can reform new bonds. So we've got, these are covalent bonds, and these covalent bonds are relatively strong. Okay, the first type here of organic reactions, and we'll do 3 today and probably 3 tomorrow. Combustion is also known as oxidation. And oxidation is commonly known as burning. And alkanes like methane, propane, right? A lot of people use propane as their fuel to heat up their house, or you've got a barbecue grill maybe that has liquid propane. Okay, so alkane, they will burn in air or just oxygen. They burn in air because of the content of the oxygen. And if you want complete combustion, and if you need to be reminded of that, complete combustion is something that we try to accomplish in lab, because if you have incomplete combustion, you can have different products, and you will have different products there. So if you've got incomplete combustion, it's basically when you're lighting a match. You can see how yellow that is. That yellow is something that we don't want when we have the Bunsen burners going. Okay, so if it's what's coming off of here, if I were to put something glass under there, it gets all sooty, and because of that, that's evidence actually of the incomplete burning of it. So in order for complete combustion, we want excess of oxygen. We should have a high temperature, and as a result, carbon dioxide and water are formed. And this is something that you should already recognize. Combustion was one of the 5 types of reactions that we learned about earlier in the year: single replacement, double replacement, combustion, synthesis, and decomposition. And it's typical that we've got oxygen combining with an organic compound like methane or propane or ethane, butane. butane is the stuff that's in lighters. And then you get carbon dioxide and water. Okay, so there has to be enough oxygen there. If there's incomplete combustion, there's a limited amount of oxygen. The temperatures might be lower as well. And water, instead of carbon dioxide being formed, carbon monoxide or carbon. And that's the evidence that you would see on the bottom of your glass. Some of you have already done that. Why is there black soot, essentially, on the bottom of my beaker? Well, it's because you didn't have enough oxygen being fed into the Bunsen burner there. Okay? So in this case, an incomplete combustion, you're still combining it with oxygen, but you end up with carbon monoxide. And you should be careful of that, because carbon monoxide will outcompete oxygen on red blood cells. Remember, red blood cells are the cells that carry oxygen in your body. So if the carbon monoxide crowds out the oxygen, then you can actually die from that, carbon monoxide poisoning. And that's really caused by incomplete combustion of maybe a faulty heater or a kerosene heater, something like that. So you should have those types of things cleaned. Okay, the second type of chemical organic reaction is a substitution. In this case, we have one or more hydrogen atoms are replaced by another element or a whole group. And this is characteristic of alkanes. Why? Because they are saturated. So in order for me to put anything else on methane, for example, I have to kick off the hydrogens, one or more of them. So this has to be substituted for by a chlorine. Okay? So here's a typical reaction. We would take methane and add chlorine gas to it, and you can get all these different kinds of products. Okay? You can get chloromethane, or this one's actually called methyl chloride, and this one is dichloromethane, trichloromethane, tetrachloromethane. This one's also called carbon tetrachloride. And this one is hydrochloric acid, as you can see. Now, there are different products here, and those really depends, which combination of these depends on how much of each. So if you have a lot of if you have a lot of methane and not that much, then you will end up with products over in this range. But if you have a lot of this and less of that, then you'll end up with stuff that ends up over in the right-hand side. Okay? So substitution, you're basically kicking out one or more of the hydrogens here and substituting that for a chlorine or maybe a bromine. Okay? Third type here is an addition reaction. And as it's implying here, the addition occurs in unsaturated compounds. Unsaturated compounds. So atoms are added at the double or the triple bond. Why? Because there's room for it. And we'll see that down here. Adding hydrogen is also possible, but requires a catalyst and some pretty high temperatures. So if you've got an unsaturated molecule, you could add hydrogen to it, and that's a process that happens down here. We'll show you that. So here are a couple examples here of halogenation. These are all addition reactions. Now the key here is that we've got a double bond, and since we've got a double bond, we can break that double bond, and then the bonds here will end up making new bonds with what you're adding. So this, we could do a halogenation. That means we could add bromine or chlorine to it, and then we end up with an alkyl halide, that's called. Okay? You can also do hydrogenation, And here's ethyne. You would be able to name that, hopefully. That's a triple bond. It's a little unclear. If I add hydrogen to it, I can make it back into ethane. Now, one thing that we could note here is sometimes hydrogenation happens when we have a liquid like vegetable oil. And vegetable oil, since it's coming from vegetables, is polyunsaturated. It could be unsaturated, it can be polyunsaturated. It depends on the oil, canola or sunflower or just corn oil. These are usually unsaturated. So because people like to spread stuff on their toast, for example, or put a chunk of something into their food, we're basically starting with vegetable oil, and then we are hydrogenating it. So here's ethyne, and it's somewhat more flexible. Bond came off here, but it's somewhat more flexible than would a saturated compound be. So you can see that these might be able to cruise by each other, and this would be in a liquid form at room temperature. But these stack on top of each other, and because of that, these are solid at room temperature. So basically, if you've got margarine, you've used margarine before, margarine, it starts off unsaturated, and then they put it through a chemical process in which they add the hydrogens so it can be a solid so you can spread it on your toast. So that's hydrogenation. Hydrohalogenation is similar in that we're breaking a double bond and then we're adding both hydrogen and a halogen. Okay? So these are addition reactions. And the last one that we'll look at today is polymerization. Poly means many, yes? So polymers are gigantic molecules formed by joining simple molecules. These are called monomers. And this happens all the time in biology into very long chains. Okay? So here are 4 examples here. And again, you don't have to have these memorized, but just understand how they're going to happen here. So basically, I'm taking ethylene in the first one, and I'm going to join it together. I'm going to break that bond, and then I'm going to join the next chain, the next ethylene together to form a big long chain. Okay? And again, you don't have to know the process, but realize that these can get extremely long. And as we'll see here, I've got a lot of examples here. These are different types of plastics. Okay, so these are all plastics. Plastics are derived from oil. Now, plastics have basically taken over all packaging. There are so many things that have plastics in them. Plastics are an incredibly useful thing. The negative on plastics is not all of them are recyclable. So they end up not breaking down in the earth for quite a long time. Now, most of your plastics should have some sort of symbol on them indicating whether they are recyclable or not. So this one, and you've seen this in new packaging, I'd rather see them use styrofoam, excuse me, not styrofoam, but starch pellets, because starch is also a polymer, but you just add water to it and it washes away. This is going to stay in the earth for hundreds of years. So this is a number 4, and I'll show you all of these here in a second. Also plastic, harder plastic. And in general, the harder the plastic, the less likely we can recycle it. Flexible. Even rubber is a polymer. Hard plastic, again, this is something you would have to throw away. All these containers, these actually are, but the cap is not. And then we've got polystyrene. You call it styrofoam. Polystyrene is another thing that really, in my opinion, should be banned because we have other things, and that really takes way too long to get broken down, and the products of that are pretty bad too. So, you may or may not have seen these before, but in Onondaga County, in your blue bin, you can put 1, 2, and 5. Now, you can bring 4, like plastic bags and such, back to Wegmans, for example. But these other things are not recyclable in this area. And why aren't they? Because no company makes money doing it. It's really economic. So PVC, this is used in piping for wastewater in your house. Maybe it's that either black or white PVC. Polystyrene, I just showed you, that's for containers, like and for cups and such. And then 7 is CDs, safety glasses that I just showed you. But all of this, they can be reused, of course, but they can also be recycled, even though we don't do that around here. So you might have heard that sometimes you can turn PVC piping back into carpet stuff and flooring. A lot of the, if you've heard of Pergo or some sort of laminate flooring that you can just click in place instead of using hardwoods, that's all it's a poly product of some sort, okay? It's all plastic, okay? So there's a lot of different things that have been used, and a lot of medical things. It's incredibly useful in that you can make all kinds of shapes out of it. Okay, this was a fabric that kind of is not used anymore. Orlon. You might have heard of rayon or polyester, right? Those are things I'm wearing and you are wearing, I'm sure. All kinds of plastic. This is cotton. Cotton is a polymer. Rayon, polyester, all of those are made through polymerization. And just another note here, condensation polymerization, I don't think it's in there, but condensation reaction is when you take water out. Okay? Natural polymers. So we've got natural polymers as well. Cotton, wool, silk, natural rubber. Wool is actually a protein, just like it's basically hair. Your hair is a polymer as well. Cotton, same thing. Silk, made by silkworms. Manufactured polymers include synthetic rubber, textiles such as Orlon and polyester, and really any kind of plastics. Okay, so we'll end there. I will post this, even though you should have your review book. Make sure you're doing the odds and the last part of 66 through 70. And then your test is going to be due by 3:15 on Friday. Okay? All right, see you then.